Claudia and with Ryan. Thanks for helping me out.
Of course.
Excellent. Okay, are we in the mood to solve this polynomial?
All day, every day.
I think so. Hey, how many roots do you think this is going to have?
3.
3, right? I don't know if they're all real. Maybe one of them is real and 2 are imaginary. Maybe, you know, who knows? But we're going to solve this. And I'm going to use a strategy that you can use to solve any polynomial as long as it has at least one rational root. All right. You know, whenever you want to look at this, you want to say to yourself, could I factor this? Like factoring by grouping, do you think that's going to work?
No.
I don't think so either.
7, 11, 2.
Yeah. Okay, so we're going to do the strategy. And that is, it's really pretty straightforward. It has 2 steps, kind of. Step 1, find a root. In other words, find one of your answers. We're going to talk about that in a little bit. Once you have your root, you're going to turn the root you found into a factor and then do polynomial long division. Okay, so turn the root you found into a factor and do polynomial long division to find the other factor. And then if you have the other factor, you can find the other roots. How do we feel? Okay, so to find a root, I basically just want to plug in a whole bunch of x's and see what x produces a 0. Now you're thinking, oh my gosh, that's going to take me forever. But we can kind of hone in on some reasonable possible roots. And the way we do that is to think, okay, if I were to find a factor, this first number here would have to be a factor of that first term. Does that make sense? So it could either be a 2x or, I don't know, a 3x or a 1x or a 6x. Those are all factors of that first term. The thing that would be here would have to be a factor of the last term. Well, fortunately, there are fewer factors of 2. So maybe it would be a 1 or a -1 or a 2 or a -2. You see where I'm going? So I could list a whole bunch of possible factors. And there's kind of a shortcut. And the way to do it, to find possible roots, you take the factors of your last term and divide it by the factors of the first term. So, you folks back home, pause this video and see why that makes sense. And I think you'll see it does. Okay. Let's make a list of the possible roots. So, plus or minus 1 is a possible root, right? Is a factor of this last term. So maybe 1 divided by 1 is a factor, plus or minus. Or 1 divided by 2. Or 1 divided by 3, plus or minus, right? Or I could do 1 divided by 6, plus or minus. You see where I'm going? Or I could do 2 divided by 1, plus or minus. 2 divided by 2, plus or minus. There are tons for this particular one. Okay? So I'm just going to dive on in and try a few of these. Now I'm going to start easy. I'm going to start plugging in 1 and -1 and just hope that one of them works. Okay? So let's plug in 1. 6 times, did that make any sense what I just did?
Mm-hmm. Yeah.
Okay. 6 times 1 cubed. They're just smiling and nodding, but okay. Anyway, 7 times 1 squared minus 11 times 1 plus 2. Does that equal 0? Let's see. That would be 6 minus 7 minus 11 plus 2. Is that going to give me 0? Sure doesn't look like it. Okay, so I tried 1 as my root, and I'm saying no. Let's try -1. Okay, I'm going to plug in -1. -1 cubed minus 7 times -1 squared minus 11 times -1 plus 2. Is that going to give me 0? Let's see, -1 cubed is -1 times 6 is -6. Negative 1 squared is positive 1 times a negative 7. Negative 11 times a negative 1 plus 2. Is that going to give me a 0? Let's see, negative 13 plus,
Positive 13.
oh my gosh, that's going to work.
Mm-hmm.
Oh, I found a root. I don't have to keep going down on my list. I found a root.
Whoa.
Yes, whoa. Okay.
So now step 2.
Now step 2. We are going to turn that root into the factor that would produce that root. What factor would produce that root?
Negative 1.
X
X
plus 1, yeah, because it is negative 1. So I'm going to take the factor x plus 1, and I'm going to divide it into this, using polynomial long division. Are we having fun yet? I know I am. Okay, x times what is 6x cubed? 6x squared. Multiply that by x, multiply that by 1, and I subtract. Those go away. Negative 7 minus 6x squared is going to give me a negative 13x squared. And I bring down the next term. I always just bring everything down. It just makes it easy. Start the process again. X times what is negative 13x squared? Negative 13x. Multiply negative 13x by x. Negative 13x times 1. And I subtract. Those go away. Negative 11 minus a negative 13. That's a negative 11 plus 13. And bring down the 2. Ooh, I'm feeling good about this. X times what is 2x? Plus 2. 2 times x is 2x. 2 times 1 is plus 2. And I subtract. And I get a remainder of 0, which, of course, I needed to get a remainder of 0, because I'm thinking that's a factor. Look what I just found. That's a second factor of this polynomial. All right, so let's keep that. I'm going to erase this whole rigmarole. And now I have factored that polynomial.
So that's the final answer?
Well, that's an excellent question. This is a partial factoring. But remember, I wanted to solve. I wanted to find the roots. In other words, I want to find all the x values that make that equation true. So
But now you have something solvable.
now I have something solvable. That's a quadratic. I could solve that if I didn't feel like factoring. Quadratic formula, right? Do you think this is factorable? I don't know. Let's see. It might be factorable. Should we try it?
It looks factorable to me.
Yeah, it might be. But again, if it's not, we could do the quadratic formula. But let's see if it's factorable. Let's see. Factors of 2, 2 and 1. Factors of 6x squared. Let's see. It could be 1 and 6. Or 2 and 3. Ooh. This is going to work. 6x and x. You see what I'm seeing? Doesn't that work?
Yeah.
6x squared minus 12x minus 1x. Hey, this is going to have 3 rational roots. That doesn't always happen. Okay, so now since this is 0, I can set each of these equal to 0. And solve each one. You don't have to write out the step, of course. There's the root I already found. This is going to give me 6x equals 1, so x equals 1/6. Hey, wasn't that on my list of possible roots?
Totally would.
It totally was. And hey, this was on my list of possible roots too. Now that doesn't always happen. Lots of times a polynomial like this could have, 2 imaginary roots or 2 irrational roots. But in this case, it had 3 nice rational roots. In other words, if I plugged all of those back in, it would solve this equation. It would give me 0.
Now I'm wondering
Yeah.
if a strategy like this could work for, say, a 5-termed polynomial.
Yes, it will work for any polynomial that has at least one rational root. But if I get a bigger and bigger degree, I mean, I could do this even with an x to the 10th with a whole bunch of terms, but it would take a long time. It would take a long time.
And would you have to guess each time? So say you came out with something like x plus 1, and then the whole polynomial that you have right there at the top, you just have to guess again. You wouldn't be able to divide to get something that you can just factor some other way.
You would just get a lower and lower degree, and each time you'd go through this process. Exactly right. Yeah. So it can be labor intensive, but you know what? It works to solve any polynomial as long as that polynomial has one rational root that you can find. Hey, thanks so much, you guys, for helping me.
No problem.